This is our first video in a series of videos about conic sections. Conic sections are probably something you studied in pre-calculus or in high school algebra. Conic sections can be defined this way. If we take a double-napped cone like this and we intersect a plane with it, and that plane is parallel to the base of the cone, well, that plane will intersect with the cone in a circle. In that case, if that plane is parallel to the base and it doesn't go through that center point there. So the intersection looks like this. Now, if I take my plane and I set it at an angle a little bit, well, now the plane is intersecting the cone in what looks like an elongated circle. We'll define that more clearly, more precisely, later when we talk about ellipses. Now we can also take our plane and we could lift it at a much higher angle so that it just intersects with this top part of the cone. So maybe it looks like this. When we do that, the curve of intersection is a parabola. And that's what this video is going to be about. And parabolas look like this, or they can face down. They can also face left or right. Actually, they can face any direction, but we're just going to look at those that are parallel to the x-axis and the y-axis, the xy plane. Now, if we take our plane and that's not going through the center. Sorry, it looks like it's going through the center. We intersect it like this. Then it looks like we've got a parabola on top, but we also have a parabola on bottom. That's not exactly a parabola, but it looks kind of like a parabola. We call that a hyperbola. It has two what are called branches, and it would look like that. Now, all of these conic sections can be defined in a simpler way. We don't always have to start with a cone and a plane. We're going to define our parabolas this way, and then we'll discuss the standard form of the equation of a parabola. So parabola turns out to be the set of all points x, y that are at equal distance. We say they're equidistant from a fixed line called the directrix of the parabola and a fixed point not on the line called the focus of the parabola. If you're familiar with parabolas, you know y equals x squared is a parabola. Let's just draw our standard parabola, our familiar parabola. And I'm going to try to do a decent job for you. Trying to keep everything to scale, it's kind of hard to do. When x is 0, y is 0. When x is plus or minus 1, positive or negative 1 squared is 1. Positive 2 squared is 4. Negative 2 squared, that's negative 2 times negative 2 is also 4. So we get this. And there is a focus, which is up here, and a horizontal line down here, which we're going to call the directrix. Now, in order to find the location of the directrix and the focus, we need to look at the equation of a parabola in standard form. There are actually two equations. If you have y raised to the first power and x being squared, this is the standard form. In that case, our standard form is x minus h squared equals 4p times y minus k. And this is where y is raised to the first and x is being squared. If this is the form of your equation, your parabola is going to open up or down, depending on the value of p. So here's our standard form. The vertex comes from the number that we're subtracting from the x and the y. So we'll call those h and k. If p is positive, your parabola is going to open upward. If p is negative, the parabola opens downward. Now the directrix is below the vertex. Below or above the vertex, depending on whether your parabola opens upward or downward. The focus is always inside and the directrix is always on the other side of that parabola, excuse me. And since we're dealing with ones that are opening upward and downward, the directrix is a horizontal line, so it's going to be y equals. We're going to take the y value right here, which in general is y equals k, and we're going to subtract p from it. Now the focus is p units on the other side. So we go p units down and p units up. P units down to find a point on the directrix and p units up to find a point on the vertex. Or excuse me, a point where the focus is, the location of the focus, excuse me. So if I go up p units from hk, my x is still going to be h and my y is going to be k plus p because I've added p to it. Now, if p happens to be negative, this is below. If p happens to be negative, we're subtracting a negative, so it's above. So the sign of p really takes care of the locations of all of these guys. Now, to be perfectly honest with you, I don't have any of this memorized at all. What I have memorized is this form, how to identify the vertex, and what p tells me about what the focus is. The focus and the directrix are the absolute value of p units from that vertex. So once I know my vertex, I'm going to go p units up and p units down to find a focus and a directrix. And if the parabola opens upward, the directrix is below it and the focus is above it. If the parabola opens downward, the directrix is above and the focus is below. So, okay, so we're going to take our standard parabola, y equals x squared, one that we're very comfortable with. We're going to write it in this form. Well, to write it exactly in that form, I guess I need to put the x on the left and the y on the right. Doesn't seem to matter though, right? My vertex, I think we all know from pre-calculus that the vertex of this guy is 0, 0. Looking at this form, I can tell it's 0, 0 because I'm not subtracting anything from the x or from the y. Now, the number in front of the y, that is 4p. So there's an implied 1 here. So 1 is equal to 4p, and I can solve that for p. P is 1/4. Since 1/4 is positive, the parabola opens upward, as we already knew. And my focus is 1/4 of a unit from here, and my directrix is 1/4 of a unit down here. And the directrix is an entire line. It's a horizontal line, and that focus is this point here. So the focus in this case is x equals 0, y equals 1/4. The equation of the directrix, we were at y equals 0, now we're going to be at y equals negative 1/4. And now I've got my vertex, my focus, my directrix, and the equation, or in the graph of the parabola, y equals x squared. That's our first example. And I think normally when we're asked to do an example, we're asked for all of these things. Find the focus, 0, 0, or find the vertex, 0, 0. Find the focus, 0, 1/4. Find the equation of the directrix, and y equals negative 1/4, and so on. And then graph the parabola. We didn't need all of this to graph y equals x squared. We already know what that looks like, but this is a really good starting point. It's a good place to start practicing, trying to write our equations in standard form and then identify the vertex, the p-value, the directrix, and the focus. And remember, this distance from the vertex to the focus is the absolute value of p. It's very small here, but that distance is the absolute value of p. Now, I wanted to draw this picture for you. I tried very hard to draw it to scale so that we could see this property. Remember, we said earlier that the parabolas are defined this way. A parabola is, the set of all points x, y that are equidistant from a fixed line called the directrix and a fixed point not on the line called the focus. Now, it seems odd. What are we saying there? We're saying, okay, here's my focus at 0 and 1/4. The distance from 0 and 1/4 to that point 1, 1 is the same as the distance from that point 1, 1 to the directrix right there. The distance from here to here is equal to the distance from there to there. Or similarly, the distance from here to the point 2, 4 is the same as the distance from the point 2, 4 down to the directrix. That distance is equal to that distance. That distance is equal to that distance. Here's a point. That distance is equal to that distance. That's what we're saying when we're saying that we're looking for the set of all points that are equal distances from the focus and the directrix. Okay, so that is one equation of a parabola in standard form. And these are the only two types of parabolas we're going to look at. And we're going to have y is equal to x squared or x is equal to y squared. Actually, that might actually not be true. Let me qualify that. I have a sense that you could have a parabola on its side. It wouldn't necessarily have to be written as y equals written in this form. It doesn't have to be opening upward or downward, left or right. It could open on an angle. But we were never taught about standard form of parabolas that open on an angle. So all of our parabolas are going to open upward or downward or left and right. Now, if you're saying to yourself, when I look at the equation, how do I know it opens upward or opens up and down or left and right? It opens up and down like this, one of these, if y is raised to the first and x is being squared. So I'm just going to say, use this when y is raised to the first power and x is squared. Now the other standard form is best illustrated this way. It's when x is equal to y squared, or when you have an x to the first in your equation and a y squared in your equation. Notice the forms are pretty much the same. They're almost identical. We just swap out the y minus k over here and the x minus h over here. This is when x is raised to the first and y is being squared. In those cases, the parabola is going to open either to the left or to the right. The vertex is still at hk. Don't let the orientation of this equation bother you. X or h is still being subtracted from the x. K is being subtracted from the y. So this is entirely determined by the x and y. It's not determined based on whether something is on the left side or the right side. In this case, if p is positive, our graph opens to the right. If p is negative, the graph opens to the left. And the directrix this time is a vertical line, x equals h minus p, and the focus, well, I'll come up with the equation for the focus in just a second. So let's look at an example. We'll start with a very simple example. Let's say we have y squared equals negative 4x. Now, you might be familiar with this written this way, x equals negative 1/4 y squared. So I might think of that 1/4 as being a compression. Multiplying by a -1 is flipping that parabola from the right to the left, and so on. But I think we can all see that when x equals 0, y equals 0, and when x equals -1, y squared equals -4 times -1, which is positive 4. So y is going to be either 2 or -2, because 2 squared is 4 and -2 squared is 4. So our parabola looks like this. I mean, we could do a better job with it. It's just very wide. Could do a better job by sketching more points. I'm trying to make it symmetric, but I'm doing not such a great job. Okay, so here's y and there's x. Okay, so just by plotting points, when x is 0, y is 0. When x is -1, we get y squared equals 4, so y equals plus or minus 2. I was able to sketch this parabola. Now, instead of using this method to sketch a parabola, let's use standard form to sketch this parabola. So I'm going to start focusing, get it, focusing, back up here. And the first thing I'll do is look for my vertex. Well, I'm not subtracting anything from the x or the y. So the vertex is 0, 0, which is just what I would have gotten the other way. Now the number in front of that variable that's raised to the first, at -4, that has to be 4p according to our formula. So 4p is equal to this -4 from right there, the coefficient of the variable raised to the first, and then we solve for p. So we divide both sides by 4, and we get p equals -1. Since p is negative, that tells me that since my x is being raised to the first and p is negative, my graph is going to open to the left, which is consistent with this picture right here. Okay, now remember, the focus and the directrix are absolute value of p units from that vertex. So the absolute value of p is the absolute value of -1, which is 1. So the focus is 1 unit from the vertex, and the directrix is 1 unit from the vertex. But the focus is always inside that parabola, so the directrix is over here. Since I understand this property that the focus and the directrix are absolute value of p units from that vertex, I don't really have to memorize anything like this. Instead, I just use my graph, I plot a point, and then I can see from my graph what the equation of the directrix would have to be and what the focus would have to be. The directrix is given by the equation x equals 1, and the focus is over here at x equals -1, y equals 0. Okay, so if someone asked me to find the vertex of this equation, find the vertex of this parabola, find the focus and directrix, that's how I would do it. First, I would plot a few points if I can. First, plot the vertex, and then choose a value of x so that this side is positive. That way I've got a perfect square equals a positive number. And then I just solve for y. So when x is -1, we get y squared is 4, so y must be plus or minus 2. Then once I've plotted those 2 points, I know that my focus has to be here and my directrix is over here. So next thing I need to do is identify P. I know how many units do I need to go in this direction to find the focus? How many units do I need to go in this direction to find the vertex? So we look at the coefficient of x, we set that equal to 4p, and then we divide both sides by 4 to get p by itself. Since p is negative, we know it opens to the left. And then since the focus and the directrix are absolute value of p units from the vertex, this distance is the absolute value of p, which is 1, and this distance is the absolute value of p, which is 1. I can plot that point and that point, and I know the one inside the parabola is the focus, and that other point is just a point on the directrix. Okay, so that is the second type of standard form for the equation of a parabola. I guess just looking at this picture, I see I'm starting at the point HK, and then I'm subtracting P, or excuse me, adding P to the X values. So the focus is H plus P and K. So we were at 0, 0, and then we're going to add P, which in this case is -1, so we end up with at -1, 0. But again, I don't memorize this. I remember the standard form, the vertex, whether P being positive or negative tells me the graph opens to the right or to the left, and the fact that the focus and the directrix are absolute value of P units from the vertex. I keep saying that, I haven't written it down yet, I guess I should write it down. The focus and directrix are absolute value of P units from the vertex of the parabola. Okay. Now, remember the definition of the parabola again. A parabola is a set of all points x, y that are equidistant from a fixed line called the directrix and a fixed point not on the line called the focus of the parabola. So what is that saying? Well, that's saying the distance from this focus to that point on the parabola, which I can see is 2 units, happens to be the same as the distance from that point on the parabola to the directrix, which is also 2 units. And the distance from this point on the parabola to the focus is equal to the distance between this point on the parabola to the directrix. That one doesn't look right. That's because I'm probably just not drawing my graph completely precisely. Or maybe my, yeah, I don't know, something not quite right about it. But this distance is equal to this distance, and if I had drawn my graph correctly, this distance would be equal to this distance, and this distance would be equal to this distance. That's what we're saying. That's the definition of a parabola. Okay. Now, when you're finding equations of conics, most of the time, they're not written in standard form, so you've got to complete this square to write them in standard form. But we know that the graph opens to the left or right whenever x is raised to the first. Now, often we'll have to complete the square to do this. Now, the next 2 examples that we'll do will involve completing the square. Or excuse me, the next 1 example that we'll do. With these problems, you tend to be given one of 2 things. Either you're given the equation and you're asked for the vertex, the directrix, and the focus, and then you're asked to sketch the parabola. Or you're given the vertex, directrix, and focus, or other information about your parabola, maybe even the value of p. You're given some information, and then you're asked to write the equation of the parabola, and then sketch the parabola. So I can either give you the equation and ask for this sketch and this information, or I can give you this information and ask for the equation and the sketch. Either one is fine. So let's do one where we're given the equation and we're asked for this information in the sketch, and then we'll do one that's the other way around. So let's say we have x squared plus 6x plus 8y plus 25 equals 0. And we're asked to find the vertex, focus, and directrix of the parabola. And we're also asked to sketch the parabola. With an equation, or with a problem like this, excuse me, I always start by identifying which variable is squared and then writing down the appropriate standard form. Since x is being squared and y is raised to the first power, this is our standard form. We're going to have x minus h squared equals 4p times the quantity y minus k. Notice y has a coefficient of 1 here. We're subtracting k from it, and then we've got this coefficient out front, and that tells us the value of p, or allows us to infer the value of p. Over here, you've got a perfect square involving x. X also has a coefficient of 1. H and k are the coordinates of the vertex, and p tells you whether this graph opens one way or another way. Now, since this is like y equals x squared, if k and h were 0 and p was 1/4, we'd have y equals x squared. These parabolas open upward or downward, depending on the value of p. So I'll say, since this is similar to y equals x squared, the parabolas open. The parabola will open upward or downward, one of those. Okay, so we've identified the appropriate standard form. Now we need to write the equation in standard form. And the way we do that is we collect all the x terms on one side, because that's going to contribute to our perfect square, and move all other terms to the other side. So I've got x squared and 6x. I'll keep that on the left. And then I will subtract 8y and 25 from both sides. And then right here, I will complete the square so that I'll have that when I'm done. Now, if the x squared has a coefficient, you would have to factor that out from everything and then divide by it. Since we don't have a coefficient, there's an only coefficient here is an implied 1. B is 6. I'm going to take half of that. That's 3, and square it. Add that to both sides. Now on the left-hand side, that's a perfect square. And on the right, that can be simplified. That's negative 8y. Negative 25 plus 9 is negative 16. And I ask myself, what two numbers multiply to give me 9 that add to 6? Positive 3 and positive 3 will work. Now remember, the right-hand side has to look like that. So I have to have y plus or minus a constant in parentheses with a coefficient out front. There's no coefficient, it's implied 1. But I've got a negative 8 here. To make this pattern match, I need to factor out the negative 8 from the y term and the negative 16. So factor out negative 8 from both of them. Negative 8 times y gives us negative 8y. Negative 8 times positive 2 gives us negative 16. And now our equation is in standard form. So we're going to compare it to this equation, plus minus, and use our comparison to identify h and k and p. So we wrote the equation in standard form. That's usually part of the problem statement. It wasn't this time, but it often is. Write the equation in standard form. We have. Okay. And now we want to identify the vertex. And P. The vertex comes from whatever we're subtracting from the x or the y. Generally, h and k are going to have the opposite sign of what you see there. That's a plus 3, h is a minus 3. That's a plus 2, k is a minus 2. And p can be found by setting the coefficient outside that y plus 2 equal to the 4p. We set those equal to each other and solve for p. Divide both sides by 4. You get p equals negative 2. Since that's negative, well, that tells us, remember, this is similar to y equals x squared. The parabola would either open upward or downward. If p is positive, it opens up. If p is negative, the parabola opens downward. So even though I didn't write it over here in my steps, I guess I should have. We identify the vertex and P, and then we decide whether the parabola opens left or right or upward or downward, depending on the form of your parabola. Okay, so I've got my vertex. The next thing I want to do is I want to graph my parabola, and then I'll use my graph and properties of the directrix and the focus to find the ordered pair, which represents the focus, and the equation of the directrix. So we're going to start to graph our function. And I guess it is a function. It's y is raised to the first. But in general, these are relations. Conics tend to be relations. Okay. So we're going to start with this. Oops, I guess I should have made it a little less symmetric around the y-axis. That's all right. The vertex is at negative 3, 2. Excuse me, negative 3, x equals negative 3, y equals negative 2. That's the vertex. Now, the focus is absolute value of p units from the vertex. So we're going to go, since this opens down, we're going to go up 2 units. Absolute value of p is 2. We're going to go down 2 units. Absolute value of p over here is also 2. Oops, it only looked like I drew the right thing. And since our parabola opens down, I know this is the focus, and the directrix must be on that line. I'm going to use a blue highlighter for the directrix. Actually, I think it might be time to retire this highlighter. It's not working very well. Use this blue marker. And of course, the equation of that line on the x-axis is y equals 0. And that's our focus over here. Focus had the equation, we were at -2, or excuse me, -3, -2, and we went down 2 units. So x is still -3, and y is -4. Okay, and our parabola opens downward. Now, I'd like to do a better job with my graph than this. I know if I'm not worried about the shape of the graph, I would tend to just draw parabola opening downward and saying that's good enough. But if I care about the shape, if I want it to be sort of the right width, then I really should plot some points. I really should pick out an XY pair that satisfies the original equation. So in order to do that, I think I will actually, let's say, let's let y equals 0. So we're on the y-axis here. Then our equation becomes x plus 3 squared equals -8 times 0 plus 2. Just replacing the y with 0. Oh, y equals 0, that's not going to work. That's the directrix. What I was thinking, doing incorrectly, I was thinking about this vertical line, x equals 0. Our parabola will cross that vertical line, x equals 0. So I'm replacing the x with 0. So we have 9 over here equals -8 times y plus 2. So we have -9 over 8 equals y plus 2. And if I solve for y, I get y equals -9 over 8 minus 2, which is 2 over 1. You can get a common denominator if you want to. -16 minus 9 is -25 over 8. This is -3 and -1/8. -3 minus 1/8. So why did I do all of that? Because I wanted a point. I wanted a point on my parabola. So that means xy equals 0 and -25 over 8 is on my parabola. So -3 minus an 8. And this is symmetric. So if I go 3 units over here in this direction, out here at -6, I should also get 3 -25 over 8. So my parabola must look like this. Tried to make it symmetric. Maybe I didn't do the best job, but that's the idea. So if somebody asked me for the directrix now, the directrix is a horizontal line, y equals 0, and the focus is this point, x equals -3, y equals -4, and we graphed it. Okay, so that is one way that we can pose these problems to you. We can give you the equation, ask you for the vertex, the focus, the directrix, and sketch the graph. You might also be asked to graph the parabola in standard form. Another possibility is I could give you that information and then ask you to graph it. Or give you that information and then ask you to write the equation in standard form and ask you to graph the parabola. So here's another example. So let's say someone gave you this vertex. x equals -2, y equals 2. And then they told you the focus was x equals -1, y equals 0. With that information, we should be able to sketch the parabola and also write the equation of the parabola in standard form. So first I will sketch it. X equals -1, y equals 2. That's the vertex. And the focus, remember that's always inside the parabola, is right here at -1, 0. And I know that this is absolute value of p units, so the absolute value of p must be 2. This is the distance between the focus and the vertex. Now if we go the same distance the other way, you find the directrix. So the directrix of this parabola is y equals 4. And we have a parabola that opens downward. I don't know exactly where it crosses the y-axis yet, but I can find it because I know what p is, and I know what the vertex is. So I see that my parabola opens downward. That means it's one of those parabolas where x is squared and y is raised to the first. Since it's opening downward and not upward, p is negative. And I know it's opening downward because our parabolas always open around the focus. The focus is always inside the parabola. So the absolute value of p is 2. The fact that the parabola opens downward implies that p is negative. So putting those two pieces together, p must be equal to -2. You want to replace h with -1, replace k with 2, and this becomes x plus 1 squared equals -8 times y minus 2 squared. That's the equation of our parabola. Now, if I want to sketch it, if I want to do a really good job sketching it, I might set x equal to 0 and figure out where our parabola crosses the y-axis. So let's say when x equals 0, what do we get? We get 1 squared equals -8. Oops, these y's should not be squared. Sorry about that. It's a parabola. Times y minus 2. So we have 1 equals -8y plus 16 if we distribute that -8. Subtract 16 from both sides. Divide both sides by -8. And so we get 15/8. It's really close to 16/8. It's really close to 2. It's just a little bit shy of 2. 1/8 shy of 2, to be precise. And because of symmetry, we're going to have the same y value on the other side. So roughly, our parabola looks like that. Okay, now let's review what we just did. In order to find the equation, the first thing I did was I graphed the vertex and the focus. And then I looked at the distance between the vertex and the focus, and I called that the absolute value of p. The distance between the vertex and the focus is 2 units. So the absolute value of p must be 2. So that means p is either +2 or -2. Sorry about that. Then I go 2 units on the other side of the vertex to find the directrix. Since I know this is the focus, I know the parabola opens around it, the directrix is on the other side. That's enough to give me the equation of the directrix. And the fact that the focus is below this point tells me the parabola opens down. And if the parabola opens down, that means p is negative. If p is negative and its absolute value is 2, p must be equal to -2. So I did all of that just from my picture, just from remembering that fact, that the focus and the directrix are absolute value of p units from the vertex. To find p, I know the vertex is -1 and 2. I just substitute those in, excuse me, and then we simplify. And I know that y is raised to the first and x is being squared because it opens upward or downward. If it was opening to the left or to the right, it would be the other way around. Let's do another one. Let's say someone gave you this information. We've got a focus at x equals 2, y equals 2, and the directrix is given by the equation x equals -2. Okay, I'm going to do the same thing. Start sketching. X equals -2 is a vertical line. X equals +2, y equals +2 is right here. That's my focus. And remember, the vertex is halfway in between these 2 points. It's halfway in between this point and that point. I think you can see in the picture. This is 2 units and this is 2 units because this is x equals -2 and that's x equals +2. So if I'm splitting the difference, I could do 2 minus -2 is 4 and divide by 2. And I'd get 2 for p, and so I would know to go here. Or you can just visually do it. Halfway in between is right here. So that's my vertex. X equals, whoops, I was right the first time. X equals 0, y equals 2 is my vertex. And I see my parabola opens to the right because it has to open around the focus. So that means, and we know that this distance from here to here is absolute value of p. Absolute value of p is 2. And the parabola opens to the right. So that means p must be positive. And if p is positive and its absolute value is 2, that means p must equal 2. Okay, I've got p, I've got a vertex. That's enough to write down the equation of the parabola. Now, since it's opening right, it's opening to the right or to the left instead of upward or downward. This time the y is being squared and the x is raised to the first. We always subtract h from x and k from y, no matter which side they're on. Okay. Now we're just going to substitute in the coordinates of our vertex and our value for and our value for p. The vertex is at x equals 0, y equals 2. So we subtract 0 from x, we subtract 2 from y. P is 2, so we sub that in. So we get y minus 2 squared equals 8 times x. And there's not really any reason to subtract 0 from it. So this is the equation of our parabola in standard form. Now, I don't really have much of a parabola here so far, not yet. I've got the vertex, or excuse me, the directrix, I've got the vertex, and I've got a focus, and I know my parabola opens this way, but I don't know exactly where it opens. So to figure out where it opens, I think I want to find the x-intercept. So I'll set y equal to 0 and solve for x. I know my parabola has to cross the x-axis sometime. So I'll figure out where it crosses. So we'll say when y equals 0, what happens to x? I've got 0 minus 2 squared equals 8x. Well, -2 squared is 4. So I guess when I solve for x, it turns out x has to be 1/2. Sort of not what I expected. I don't know what I expected. But that's our vertex, and it crosses here at x equals 1/2. And by symmetry, if I go 2 units in this direction, the x values increase by 1/2. If I go 2 units in this direction up to 4, the x values should also increase by 1/2. So we should have a parabola that looks roughly like that. Okay, so those are parabolas.